Hi friends, today we are talking about Chapter 5 multi-step equations and inequalities. Today we're going to focus on inequalities. Our first vocabulary and our only vocabulary term is the word inequality. Inequality means not equal, and particularly in mathematics it means a number sentence or a mathematical sentence that compares quantities that aren't equal using the following symbols. So the symbols that we have are, this would be less than or and equal to, less than or equal to. This is less than. This is simply not equal to. This is greater than, and this is greater than or equal to. So we'll be using the following quantities or the following symbols to represent and to compare quantities. Our first example gives us the opportunity to practice using some of those symbols. So we're going to write an inequality. Write an inequality for each of the following sentences. So this first one, the DVD costs more than $15. The DVD is certainly not $15. It is more than $15. So if we use the variable, let's say we can use the variable D for the cost of the DVD, we would say that D is greater than 15. We wouldn't use greater than or equal to because it says it's more than. Let's take a look at this next one. A dog weighs less than 50 pounds. Again, if the weight of the dog, let's use W for the weight of the dog. If the weight of the dog is being represented by this variable, a dog weighs less than 50 pounds, we would use this symbol. Let's take a look at example 2. We're going to write an inequality. Here's the situation. You must be at least 18 years old to vote. Write an inequality to describe the situation. Let's use the variable V for voting age. If you must be at least 18 years to vote, then the answer, the symbol that we would use would be greater than or equal to, because you can certainly be 18 to vote, but you can't be less than that. So the voting age must be greater than or equal to 18. Let's take a look at example 3. We're going to determine the truth of an inequality. For the given value, state whether each inequality is true or false. Let's look at part A. Part A has 2t plus 8 is greater than 7. Does this t value, if t were equal to -1, does it satisfy this situation? Let's check it out. So if I plug -1 into this inequality, I get 2 times -1 plus 8, and I'm going to see whether this part is true. Is it really greater than 7? So when I multiply that, I get -2 plus 8 is greater than 7, and that follows through with -2 plus 8 being a positive 6. Is 6 greater than 7? Of course not. So we know that this one is false. Part B, we have that p minus 42 is less than or equal to -2. Let's substitute in 40 for p. When I do that, 40 minus 42, is that less than or equal to -2? 40 minus 42 will give me -2. And when I check, is -2 less than or equal to -2? It is. Doesn't have to be less than. With this symbol says that it can be less than or equal to, and in this case it's equal to. So this is true. Here in example 4, you'll see that we have not only symbols to use to represent our inequalities, we can also graph them. So in example 4, we're going to graph inequalities that match each of the expressions, the inequality expressions that we have. So when I'm thinking about graphing an inequality, I want to show graphically all of the values that are represented here. A is greater than 6. It's not equal to 6, it's greater than 6. So I only want to include numbers that are greater than 6. Typically we start our number line with 0 somewhere. You don't have to. Make sure you put a few numbers down so we can get the orientation of your line. So I'm going to start 0 here. 1, 2, 3, 4, 5, 6, 7, and 8. Just put some numbers down so I can figure out what's going on. I don't want A to equal 6, but 6 is a pivotal point in what we're talking about. So I'm going to put an open circle at 6 because I don't want A to equal 6, but I want A to be everything greater than that. So I'm going to shade in everything to the right with an open circle. An open circle is reserved for when we don't have equal to, but we just know that we're going to compare our quantity with a particular value. So we use an open circle here. and everything greater than 6 is shaded in. Let's look at this next example. In this example, we're comparing x, and we're saying that x and -1, and we're saying that x is less than or equal to -1. Again, I'm going to jot down some terms, some numbers on my number line just so you can get the orientation. As I do that, I'm thinking about how I'm going to display this. This says that x is indeed equal to and or less than -1. Since it is equal to -1 or less than, I'm going to shade in the -1 because I want this to be included in my solution. So I know that x is equal to or less than -1. I'm going to shade to the left where all the numbers are less than -1. And this is how we graph inequalities. All right, class, let's take a look at example 5. Here we're going to write an inequality based on looking at an inequality graph. So what you want to do whenever you have a problem like this, if you have a graph and you need to figure out what's going on, you go to the number that is either circled or colored in. So in this case, we're talking about 2. Let's choose the variable x for all of these. So in this case, 2 is x, the value that we're talking about is equal to x or greater than. So we would say x, and you'd have 2 on the other side. X is greater than or equal to 2. That's what is being showed here. What about this one? If this we're referring to in part B as x, we see that the x value is less than -1, but it's not equal to. So what we would do here is say that x is less than -1. Notice we don't put an underline here because it is not filled in. It is not equal to. In this one, notice that this number line does not, part C, this number line does not have a 0. That is not a problem. It is okay once you put a number, enough numbers to understand the orientation of the number line. So when you look over here, we realize that we're not on 7, we're not on 8, we're in the center, we're at 7.5, and we're comparing x to 7.5. So x and 7.5. How are we going to compare it? We realize that x does not equal 7.5, hence the open circle, but x is certainly greater than 7.5. And that's what we've got. So now that you've completed those examples, feel free to work on your assignment. It's given in the front of the packet, and I look forward to talking to you guys tomorrow.